Hello everyone, my name is Yu Zhang. The topic of this presentation is the importance of index and compression in databases. In this presentation, I'm going to talk about what is database index and database compression and some advantages and disadvantages of index and compression and some cases about index and compression. Firstly, let's talk about what is database index. In publishing, an index is an alphabetical list of names and topics that often appears in nonfiction books. But in databases, indexes are a powerful tool used in the background of a database to speed up querying. Indexes power queries by providing a method to quickly look up the requested data. Simply put, an index is a pointer to data in a table. An index in a database is very similar to an index in the back of a table. Technically, an index is a linked copy of a subset of a table existing within the same database. It can consist of one or more columns. There are some advantages of database index. Firstly, ensure the uniqueness of each row of data in the table. The second one is the significantly faster data querying. This is most important reason why we use database index. Lastly is the accelerated to table join. The second one is most important reason. Imagine working into the Library of Congress and being given the task to find a specific publication within 10 minutes. Would you be able to complete this task with a given time frame? The Library of Congress is considered the largest library in the world, and it houses about 160 million items. Now, the Library of Congress is not a regular library where the public can check out books at will. But if you are like us, you know the challenge should not be so difficult. In fact, the first thing we would do is ask for access to the library's index because indexes contains all the necessary information needed to access items quickly and efficiently. In the same manner, the database index contains all the necessary information to access data quickly and efficiently. In today's society, the business of data is rapidly advancing. In fact, some tech giants process several hundreds petabytes of data per day. Storing all of the data in a database is great, but for a data company, being able to access that data efficiently is paramount to success. So there is a simple case of database index. This is let us to select Zach's information from the front table. To get this information out of the database, the computer will look through every row until it finds it. If the data is in the first few rows of the table, it can still be found quickly. But if a table has millions of rows and the data is at the bottom of the table, it can take a lot of time to find the data. As in this example, it takes 8 times to find the target data. So if the table was ordered alphabetically and searching for a name could happen a lot faster because we could skip looking for the data in certain rows. If we wanted to search for that and we know the data is in alphabetical order, we could jump down to halfway through the data to see if that comes before or after that row. We could then have the remaining rows and make the same compression. It took 3 compressions to find the right answer instead of 8 in the unindexed data. So what exactly is an index? Indexes are used in things like a contact list where the date may be physically stored in the order you add people's contact information, but it is easier to find people when listed out in alphabetical order. We can see here that the table has a data stored ordered by an increasing ID based on the order in which the data was added, and the index has the name stored in alphabetical order. An index is a structure that holds the fields the index is stored in and a pointer from each record to their corresponding record in the original table where the data is actually stored. So there are two main types of index. First one is clustered index. Clustered indexes are the unique index per table that use the primary key to organize the data that is within the table. Non-clustered index are stored references for a specific field from the main table and hold pointers back to the original entries of the table. But there are also some disadvantages of database index. The additional disk space and every time data changes in the table, all the index need to be updated. Each and every non-clustered index requires additional disk space as it is stored separately from the table. The amount of space required will depend on the size of the table and the number and the types of columns used in the index. When any DML statement such as insert, update, and delete modifies data in a table, the database needs to update all of the indexes where the data has changed. As we already discussed, the index can help to search and locate the rows that we want to modify. However, too many indexes to update can actually hurt the performance of data modifications. This leads to a delicate balancing act when training a database for performance. So this is the second one, the compression. The database compression is set of techniques that reorganizes database content to save on physical storage space and improve performance space. Compression can be achieved in two primary ways: lossless and lossy. The compression is also known as the source encoding or bit rate reduction. So there are two main types of compression. The first one is lossy compression. In lossy compression technique, the compression does not bring data back to its original form. It is used for music, photos, videos, medical images, scan document, and fix machines. Just like when we use YouTube, we will have different quality options. And second one is the lossless compression. In lossless compression technique, decompression returns data back to the original form. It is used for databases, emails, office documents, source code, etc. And the advantages of database compression is reductions in storage hardware. Compressed data is written faster than original data. Faster field transfer speed. And also there are some disadvantages of database compression. The first one is compression is a mathematical intense process. That compression algorithm are system intensive process and will take up valuable resources during data compression process. And when database size is small, compression fields might be larger than uncompressed fields due to additional dictionary creation. So compression must be attempted only when the gain in CPU or memory due to the optimized page width is much larger than the compression overhead. And the compression will affect some data types. It's not every data type works for the compression. The data compression applies to these database objects: heaps, clustered index, non-clustered index, partitions, indexed views. And for row-level compression converts fixed length data types into variable length types. And for page compressions is more advanced. It internally invokes row compression. For example, fields created as fixed length types, such as char 100, might not fill the entire 100 characters for every record. So this works well for fixed length text and numeric fields like char int. So this works well for fixed length text and numeric fields like storing 23 in an int column will requires just one byte uh, when compressed instead of the entire 4 bytes allocated. No space is consumed for none or zero values. Commonality in page data is extracted and encoded, one column at a time or all columns together. So the conclusion is in conclusion, database index and compression are powerful tools for optimizing databases performance. Indexing provides faster querying and retrievals of data by creating a separate structure that can be searched more efficiently. Compression reduces storage space, improving the efficiency of disk I/O operations and allowing or faster data retrieval. However, these techniques also have their disadvantages. Indexing can increasing in the complexity of database design and leads to longer update times as the index needs to be updated whenever the data changes. Compression can also lead to slower query times as decompression may be required before data can be accessed. Despite these disadvantages, the advantages of indexing and compression make them essential for large databases where performance and storage efficiency are critical. The choice between these techniques and the specific method used should be based on a careful consideration of the trade-offs between performance and storage. Overall, indexing and compression can greatly improve the efficiency and cost effectiveness of a database system. So that's all. Thanks for your time.